All right, let's talk about radians and degrees. So we know that we have two forms of measure for an angle, and those would be radians and degrees. So let's first define them and talk more about them, better understand. So 1 radian is the measure of a central angle let's say theta, that intercepts an arc S that's equal in length, Length, there we go, to the radius R of a circle. I personally always like to draw things out to better understand them rather than always just putting them in words, so we're going to go ahead and do that. So again, it's the measure of a central angle theta that intercepts an arc S equal in length to the radius R of a circle. So basically, it's the relationship of arc length and radius being the same. So think about this visually. Like, let's say we have this part of a circle. Looks like an ice cream cone. This is our angle theta. Let's say that this is R, our radius. Okay, and then we're going to have S over here, which is representing our arc length. So like I just said, we know that the arc length and the radius, that relationship should be the same. So let me scroll down a little bit here. So we know that theta is equal to our arc length over the radius. Or that's the same thing as saying that R times theta equals arc length, which is a little FYI to yourselves. You're going to want to remember this for later on this unit. Okay? One thing also to keep in mind is that when we're talking about circumference, so instead of just part of the arc, part of the circle, we're talking about the whole circumference. We know that circumference is equal to 2 pi r. We already know that, right? So that being said, if we did, instead of circumference, I'm going to write c. If we did c divided by r, so I'm just dividing both sides by r, we get 2 pi. And I bring that up because I want us to remember that 2 pi is the measure of that central angle of a circle. Okay, so really one revolution is equal to 2 pi radians. Okay, so lots of things to remember or to keep in mind about radians here. Okay. Degrees are a bit easier for us to understand just because we use it so frequently and it just makes sense to us because we have that number 360. So 1 degree is equivalent to 1/360th of a complete revolution about the vertex. That should make more sense to us, again, because we're just more familiar with it. Also, just to keep in mind, radians, although we are less familiar with it, they actually have been around a lot longer than degrees. They used to think that, obviously they used to think that it was 360 days for one revolution about the sun. So that's where this relationship is coming from. So let's talk about converting angles. There should be an N in there. Converting angles. So it says here, if 2 pi radians is 1 complete revolution and 360 degrees is 1 complete revolution, then answer the following questions. And I am going to have you guys do this on your own. What process would you use to convert an angle measure from degrees to radians? From degrees to radians, maybe you want to use an example. And what process would you use to convert from radians to degrees? So go ahead and write down your answer. So you might have had a different kind of response, more wordy perhaps. But what I would have put is just that, whatever degree measure I'm starting with, I would basically want to multiply by 2 pi over 360 degrees. And then from radians to degrees, I multiply whatever radian I have times 360 over 2 pi. But maybe you had a better answer than what I had. So let's test this out, and let's go ahead and convert these degrees to radians, and then these radians to degrees. So go ahead, put me on pause. Actually do this. I know you're not going to. Do it, please. Okay, so put me on pause. Still not kidding. Do it. Okay, so let's see. I showed my work for this first one here. So I multiplied the degrees by 2 pi over 360 and got 3/4 pi. You guys can check your answer for part B. Same thing here. I multiplied by 360 degrees over 2 pi, so I got 810 degrees. And then my final answer for letter D was negative 39 degrees. Just something to keep in mind that radians don't have to be in terms of pi. We're very used to seeing pi attached to some number and then being like, oh, that's radians. But like I could have given you just 9/2, and that's in radians. As long as I'm not representing that in terms of degrees. So just keep that in mind. Doesn't have to have pi. Okay, so let's try some of these. It says determine the quadrants and sketch the angle for which each of these would belong. Okay, so I'll do the first one with you. So I have 285 degrees. I'm going to draw it in here. 285 degrees. So I know, here's my initial side. And let's think about this. This would be 90, 180, and then this would be 270, and then of course 360. So 285, let's actually write that. 90, 180, 270. 285 must be somewhere in here, right? I'm actually going to show this would be 285 degrees. Okay, so let's have you guys try 2 and 3 on your own. Okay, if you're already confused about number 2, this is negative 332 degrees and 50 minutes, which is a part of a degree. Okay, go ahead, try it on your own. Okay, so here's my sketch. Now, I actually was kind of silly. I was just too excited about the math that I forgot to actually answer the question. The question said determine the quadrant in which the angle would lie. So for the first one, that would be quadrant 4. The second one, hopefully you guys got quadrant 1. And the last one, quadrant 4 again. Okay, so actually answer the question. Now the key thing here, there's nothing too tricky about this. It's really just having a number sense, knowing that positive 285 is between 270 and 360. And likewise for the others. So nothing too crazy here. Now these guys, this one, you're going to have a bunch of radians. Here is those examples where I said that radians don't have to have a pi. Okay. But I'll do the first one with you guys and then have you guys try a bunch. So this first one is pi over 5. So let me draw my initial side. That's an ugly color. Okay, so if this is pi over 2 and this is pi, where would pi over 5 fall? Well, pi over 5 is between 0 and pi over 2, so I know it's going to be in quadrant 1. Okay, so go ahead, try these examples, all of them. So you should have 7 of them to try. and then we'll check our answers. All right, so let's take a moment here to check our work. I'll talk about this example and then kind of let you guys figure out the rest from there. But so for the second example, it was 7 pi over 5. Now, to figure this out, let's think about like, well, what's 5 pi over 5? 5 pi over 5 would be just 1 pi, right? Oops, 5. So 7 pi over 5 would be somewhere between here and then that 3 pi over 2, right? So again, check your answers here. You know, the key thing here, again, like I said, is just having that number sense, like knowing, okay, well, we know that pi is 3.14. What's pi over 2? Half of that, right? So 2 would be somewhere in between the two of those. So check your answers there. If you have questions, make sure you start and let's talk about it in class. The last part of this is just us approximating the angle to the nearest 1/2 radian. So just approximate. Now, one thing that'll be helpful for you to keep in mind is, you know, well, let's think about what's 2 pi. 2 pi is about 6.28, right? What's pi? It's about 3.14. Okay, well, what's pi over 2? That's about 1.57. And then what's 3 pi over 2? That's about 4.71. So hopefully this will help you guys kind of approximate, again, to the nearest 1/2 radian, what these are about equal to. Okay, so let me pause. Take a guess. Okay, so you need my help. All right, so let me help you with this first one. So I know that I'm somewhere between 3.14 and then here would be 4.71. So it's either got to be like 3.5 or 4, right? Something between 3.14 and 4.71. So I don't know. Let's just say that we are going to guess that it's 4 radians. Okay. Now you can try. I realize I said that really creepy. All right, let's check. So again, these are emphasis on the word approximations. So if you have something similar to mine, or even if it's different, it is possible it still could be correct as long as it satisfies, you know, the condition. So I said -4 for this one. This would have been -3.14, and this would have been -4.71. So that's how I got that. For this third one, I had -1. Here I did 5, 1, and -3.5.